And then that way we get a true reading on the micron gauge. And speaking of the micron gauge, check this out. This is FIELDPIECE's new MG44, micron gauge 44. Super awesome display on it. Look at how big that display is. Today we have a call on, they're complaining that all their ACs are down and they're not working at all and it's not cooling. We're getting a lot of these calls lately. Honestly, I thought we were gonna have cleaning issues, but it actually doesn't look that bad right now. So we're gonna go through these units. We'll just check them all out, see if they're working. Just because they're clean here doesn't mean they're not dirty on the inside. All of them should be running right now, but I haven't gone to the thermostats yet either, so we'll check them all out. Yeah, they're all running. This one's blowing cool air out. And so is this one. This is blowing cool air too, so that's a problem. So we'll have to look into it. We'll start going through them all. All right, we're on the kitchen AC right now. The kitchen AC, we did a quick temperature drop across the supply and the return. 69-degree supply, 88-degree return, which is a little bit off because we're pulling a little bit of outside air. So that's an issue. We come over here, only one compressor is running, the other one's not. The economizer module says outdoor air sensor error. Don't know if that's a problem or just, you know, or the problem or just another problem here. We go from Y1 to C, we get 25 volts, that's first stage. And then we go Y2 to C, 25 volts, that's second stage. So we should be calling for second stage, but if we go across the second stage low pressure controls right there, let's go across that. Okay, so I'm on the second stage low pressure control and I have 25 volts. So that means that the second stage low pressure control is open, and that's a problem. So we need to figure out why that low pressure control is open. Is the system out of gas? Who knows? We'll have to check that right now. Also at the same time, this unit is dirty, I can tell on the inside. It's really dirty. So we're gonna go ahead and clean this guy too, but we'll go ahead and put some, we'll shut it off and then we'll go ahead and check on the belt, look at the evaporator, look at the filters, and then see if there's refrigerant in the second stage. This is my second stage compressor and it's out of gas. I just depressed the Schrader, barely anything came out. So it's completely out of gas. So we gotta look for signs of oil. So the second stage is gonna be the top half of the evaporator and the top half of the condenser. I mean, there's, you know, dirt and stuff everywhere, but I don't know if that's a leak. So we're gonna need to probably pop the top on this guy because I want to split the condenser and clean the inner condenser anyways, and then we can go ahead and put some nitrogen in it and look for a potential leak too. So I still have no obvious signs of a leak, but we went ahead and split the condenser so we can get down into there. We're going to go ahead and give it a proper cleaning, clean out the whole inside, get all this, and then we'll do a leak test on it. The evaporator doesn't look too bad either, but I think I remember cleaning this for some reason. I remember pulling this assembly out and degreasing it, I think. I don't know. But yeah, this doesn't look too bad. I was surprised. We just unclipped, there's little clips that, you know, fasten the condenser together. But we'll get this guy washed out and, you know, with the brightener. We're using the blue brightener venom pack in the foam gun. I can find it, this stuff right here. I figured I was gonna clean most of these ACs, so I filled this guy up. Now this amount of the venom pack is like 16 bottles. I mean, that's a lot of cleaner, so keep that in mind. Cleaner's been sitting on there for a few minutes. So we're just gonna take the hose, kind of go to town, let it wash the stuff out. You can see it's coming out nice and nasty out of there. But you gotta be careful because when I'm washing the inside one, it's blowing it onto the outside condenser, so you're gonna have to rinse it really good. But this water, using the water like raw like that without a nozzle on, it's actually working out really good. Does a good job of pushing all the stuff through. So we're gonna slowly clean it all the way down, clean the whole inside of the unit out. You can see it's coming out nice and dirty. We got two people up here, so we're gonna be bouncing all over the place. So this is the unit that the condenser fan motors were running, but it was not rejecting heat. It was just lukewarm air. So we come over here, both the compressors had ice going to the suction lines. We come into here, the indoor blower motor is not running. This unit has a VFD, variable frequency drive, that slows down and speeds up the motor to meet energy requirements. It basically makes this a 2-speed unit. On first stage, the motor runs at the predetermined lower speed, and then on second stage, it runs at the predetermined higher speed. But anyways, so this guy was not allowing the motor to turn on. We checked fuses going into this guy, and all 3 fuses are blown. These are little 20 amp tiny fuses, and I don't know if I'm gonna have these or not. These are a pain in the butt to get. And they're super expensive. I wanna say these things are like 15 or 20 bucks each. It's nuts. So we pulled the fuses out. The fuses were blown. The next thing we did was we tested the wires to the motor to make sure it's not grounded, and we got no shorts to ground. So then again, because I'm assuming Carrier assumes there's going to be failures, they send them with the male and female connectors, so that way you can bypass the drive to troubleshoot. You see this? So power coming from the fuses now. All that I did was unplug, and here's the wires going to the VFD. Literally have the quick connects already on them, and that's factory. Nobody added that. That's how they come. So it's like super easy to bypass these drives. Now, something to understand, when you bypass the drive, you are taking out the motor protection, because this drive protects the motor. So always keep that in mind. Usually bypassing a drive is just for troubleshooting purposes. These do not come with displays. I have a display, but I'm not even gonna try right now. It's really silly. So we're gonna go down and see if we have some of these fuses and if this motor will start up and we could possibly get this unit running. It's gonna more than likely be a triage situation, because we're probably gonna focus on that kitchen AC and finding the leak. I'm just about done rinsing it off, and then we'll go through and troubleshoot the rest of the units. All right, back on the AC. It's completely out of refrigerant on the first stage. So what we're gonna do is go ahead and put some 410A in there as a trace gas, and then we're gonna stack our nitrogen on top of that to try to find the leak. So let's put it in through the high side. Gives to about no more than 50 PSI. All right, so keep in mind that using 410A as a trace gas is legal. You are allowed to do that via the EPA. If you remember when you took your section 608, you are allowed to use it as a trace gas refrigerant as long as you put nitrogen on top of it and it's not a massive amount. So we're putting it on there. We're gonna get to about 250 PSI with the nitrogen and 410A, and then we're gonna go to town, try to find a leak, okay? I wanna show you something too. You notice this one, the wiring is ran where it should be, and it goes directly into there. It's not running to stupid wire nuts and stuff. I appreciate that so much. All right, we're just about there. So we'll get it to 250 and then we'll get the leak detector out. All right, so we put the fuses in there and it's running in the right direction. We need to put the panel on it. We'll take this one off and we'll test current on the motor to see if there's anything wrong with the motor. It's probably just gonna end up being a bad drive more than likely. So the first thing I did was I took my service gauges off, put them over there, because I wanna test the Cormax fittings too, because those leak all the time, okay? So we're gonna come onto this guy, kind of just, I rinsed everything off too to try to get any residual refrigerant blowback from when I took the gauges off. Nothing. So then what we're gonna do is just go for the obvious places. Start at the condenser and work our way up. Right about in this area. Kind of working our way up. See that? Something's in there. It's every once in a while picking something up, right where, right up in here. The lighted tip is lighting up. It's like right around in this area right here. It's like picking something up. There we go. Right there. So what we're gonna do, we know it's in that area somewhere. We'll get some big blue soap bubbles on there. All right, so when you use the big blue soap bubbles, there's two settings. There's the fan setting that you can spray like that, okay? Now you tell me something. How does that look? That's kind of counterintuitive, and it's not very smart to use that setting, because check this out. If you use the stream setting, it doesn't make bubbles, and you can pick up micro leaks that way. So I always use the stream setting and do it nice and slow. I don't blast that crap on there. So what we're gonna do is just liberally apply this up in here. You can see I could just go to town with this stuff. If you spray it on carefully, it doesn't create any bubbles. And then that way, if you see bubbles, you know it's a leak. It's easy as that. All right, there we go. Right there. That sucks though, because that's in a spot where I have to cut open the condenser to fix it. Like, that's going into the condenser. Luckily it's on the outside, but still that sucks. So we came back over here. Once we closed up the panel on this blower motor, it's running at 4 amps and we're allowed to run somewhere in 8-ish amps or something. So I don't know that there's anything wrong with that blower motor. So we're going to put this unit back together and see if it gets a good TD once the blower motor starts running. It might be all that it takes, and we can address the VFD issue at another time. I'm not going to deal with that right now. We'll just leave it bypassed temporarily. All right, I got my die grinder, and then I also got my Dremel tool, and we're going to try to get in here. And I marked it. This is it. We're going to try to cut back, get this separated to where I can get to the inside of that pipe. We might have to torch it a little bit too. We'll see. All right, let's try not to cut my head off here. Okay, that gets us a little bit closer. This is just baby steps. You just got to do this nice and slow. You get in there, start cutting it back further and further. And this can be a permanent repair if we do it right. All right, so obviously I made the leak bigger, but I was able to fully get around this line, and I peeled back the metal where it's not strained on anything else. And we'll be able to get in there and sand it. And we'll sand it all up and then put some braze joints on it. We'll also lay a braze right here because I nicked it, and then also on this dryer because I nicked it right here too. So we'll make sure we take care of all that, and we'll get some nitrogen flowing through this guy. But first I got to get it all sanded up and cleaned. I got in here and I sanded everything as best as I could. There was a little bit of like damage right here. It was like dented or something from me pushing around in there, so I'll lay a bead on that. We'll lay a bead on that. And then we'll also fix the top of this right here where it kind of rubbed out a little bit, kind of funky. We got to get that dryer undone, but we're pretty much ready to braze. I've already got the nitrogen flowing through the system. The nitro tank right there. So yeah, we're just about ready. If you can get some of that, that'd be great. Make sure, does it still show? Yeah, sideways. Try to get a little bit of me, and then when I'm done talking, pan to the brazing. Right. Okay, so I've got the new dryer installed. We've brought some heat blocking compound. It's not going to be perfect, all right? And I know a lot of people freak out about this, but I had to unsweat the dryer. There's nothing else I can do, okay? You can only do it so much. And I realize everybody thinks I'm going to release all the moisture into the system. But you got to do what you got to do, okay? Sometimes you can cut the dryers out, but this one I would have had to repipe everything, and I didn't want to do that. So we got to sweat in this dryer, and then we're going to sweat in all the little spots in here. So we're going to get going on it. I am using a 0 tip, so it's very minimal on the heat. It's gonna be nice and slow. Let's see what we can do here. is where it gets tricky, because we don't want to melt everything else, and this condenser has really thin copper on there. So you literally need to drip the solder on and let it go around. You don't want to try to heat it up like normal copper, because it'll flare up and then we'll be SOL. And you're going to use a lot of it, it's going to look ugly. It's okay. Nothing wrong with too much. So it looks decent, but we're gonna do some inspections with mirrors too. I think we're gonna be okay though. Getting in here, I cleaned it all off. You always wanna inspect every braze joint with the mirrors. Just go in here and really look. It's always better to do it that way. So we're ready for a nitrogen pressure test. I got the dryer secured back in there. So I'm gonna jump out of here and get the nitro on it and make sure we don't have any more leaks. So far so good. I sprayed Big Blue all over everything and I'm not getting any bubbles. We're doing a tightness test right now, so we're gonna let it run for a little while and kind of see where it goes. All right, we are evacuating the system. So currently I am doing a 2-hose pull on this guy, okay? And we eventually will shut off this hose and just pull from the suction line, but I like to get the initial pull down and then shut off the hose. And then that way we get a true reading on the micron gauge. And speaking of the micron gauge, check this out. This is FIELDPIECE's new MG44, micron gauge 44. Super awesome display on it. Look at how big that display is. It will connect to your phone using the JobLink app, so you can see it on the JobLink app. You have alarm features all up in here. It's pretty cool. So we're gonna let this thing run for a little while and start assembling it, putting the top back on and stuff, and just kind of getting ready to charge the system up. All right, I'm gonna close the gas ballast at this point, okay? So that way it starts really pulling through the oil. And I went ahead and valved off this core removal tool. So that means that it's no longer pulling through this hose and it's only pulling on the micron gauge, which now put the micron gauge at the furthest point from the vacuum pump. So now the vacuum pump is pulling through this hose into the suction line, all the way through the evaporator, all the way back through the condenser, coming back on the discharge line and pulling on this right here, okay? So it's also okay for it to rise a little bit too when you close this off, because when you were pulling on it, when I was pulling on it originally, it was pulling, you know, through the gauge before it actually went through the entire system. So that's why it's so important to have the micron gauge at the furthest point away from the vacuum pump, if possible. So notice that, yeah, see, we just started rising like crazy right now because it finally caught up, and that's okay. It's not the end of the world. It's natural for that to happen because it's got to kind of recover, and eventually it'll start dropping again, okay? But that's all because I started an initial pull with both hoses and then I closed the core removal tool. So you also have the ability to use the app, like I said, and log it. So it's charting it basically, so you can see the actual drop and how it's working and what's going on with it. So really cool. We're still letting it evacuate, but what I did was I put the panel up there kind of halfway and turned the unit on so the first stage can turn on and get that kitchen some cooling. I'm able to watch it on my phone right there. So we're at 554 microns and we're still pulling down. So we're gonna let it go a little bit lower and then we'll do a decay test. All right, we are in decay now. You can read it on there, you can read it on here, either way. We're just letting it sit, but I'm pretty confident we're good to go. So we'll let it sit for a few minutes and then we're gonna get ready to charge this guy up. So one of the downsides about using 410A with the higher pressures and everything is you always end up with a little bit left over in the tank that's always hard to get. So I had a tank here that had about a pound or two in it. So I initially pulled all the refrigerant out of that with my vacuum, okay? So I was able to get a pound out of that guy. You got it on both of these. That's the cool thing about the wireless scale, is you can see it on the manifold and the handle, but pound 2 ounces. So now I have a brand new full drum right here that we're gonna use to finish the charge on this guy. So I think I've shown this before, but there's a trick. So I use that other cylinder, right? And I'll put this right here so you guys can see better. Okay, so I used that other cylinder and I used a pound 2.25 ounces out of it. But then I go to put this new one on there and it says 23 pounds. So now I lost my pound 2.25 ounces. So I'll show you a trick. Zero it out. Okay, let's do this right now. Zero weight. Okay, so now both of them say 0, right? Then what I'm gonna do is I'm gonna take my hand and I'm gonna push down on it till it says a pound 2.25 ounces, and then we're gonna 0 it. All right, that's close enough. I got it to 1 pound 2 ounces. That's good, right? So all I did was push down on the scale, right? You see how that one's changing, and then zeroed it out when it got to the 1 pound 2.25 ounces. So there we go. That's good enough so we can continue charging, but we're gonna have to turn the system on and charge in through the, well, we'll put a little bit through the, okay, make sure that guy's good. And we'll go ahead and put, yeah, we'll see if it'll take some more. Yeah, it is. It's taking more through the high side. So we'll charge as much as we can through the high side, and then once it won't take any more, then we'll close it off and start the unit up and charge it in through the low side. All right, I'm waiting for the second stage to turn on. The first stage just turned on. Another tip here is we're reading pounds and ounces, right? But they give you the unit charge in just pounds, so it's 10.2 pounds. Change your units to read pounds, and then when it says 10.2 pounds, it's the exact same thing. Now 10.2 pounds on there is not 10 pounds 2 ounces, so you got to do the math, and I'd rather not do the math, so I just changed the scale on the scale. All right, it just turned on, and so I'm adding it as quick as I can before it goes off on low pressure, being careful to not you know, hurt the compressor with liquid refrigerant, but it is a scroll, so it should be pretty good. Watching the weight as I'm going. Now I never zeroed out this one, you know, when I put the new drum on there, so I'm only paying attention to the top now. But yeah, just adding refrigerant, we're almost there. Okay, so we made it to the 10.2 pounds. That was the factory charge. Mind you, it says 10.2 pounds. Again, that is not pounds and ounces, that is just pounds. So it's not a huge difference, but if you change the units to pounds and ounces, that's 10 pounds 3.25 ounces, okay? But it's 10.2 pounds. Again, I didn't want to have to do the math, so I switched it in the units. But yeah, we're looking good. We're gonna watch this thing operate for a little bit, make sure everything's good, make sure the temperature split's good. And yeah, we're just about done. We've been cleaning all the other ACs, washing them off, checking the belts and stuff, so we're looking pretty good. We got a nice mess of coil cleaner and stuff up here, but. So I closed off the high side, and I'm putting the refrigerant from the high side. I closed off the process port and I opened up the high side, equalized out the gauges so that way it's sucked in as much as possible. We can go ahead and shut this guy off and then just kind of verify everything's working properly. Everything looks good, no refrigerant leaks. I mean, the repair kind of looks a little butched up, but it works. It's functional. Being careful not to you know, overheat every other joint in there. So I use a number 2 or a 0 tip actually on that. So yeah, all is well. We're gonna just start wrapping everything up. Now I gotta deal with the aftermath of all this junk. Still got more stuff on the roof. I'm hot and I'm sweaty. It's 100-ish outside, but I'm trying to kind of piece it together and put everything where it goes because I'm sick of my messy van. That was a frustrating call because we had already worked a full day and we got to the location around 12 o'clock noon. And, you know, they said they had a few ACs down, but it turned into, you know, obviously they had a few ACs down. They had several dirty ACs. So I had myself and another technician there, and we were just going through everything. I was kind of letting him do most of the other stuff, the cleaning and everything, and I was kind of bouncing between, just giving a little bit of assistance here and there. But I was focusing most of my efforts on the kitchen AC because I had found that refrigerant leak. So, you know, cutting into that condenser like that, it's going to be okay, right? It looks like a butch job. And, it, you know, I mean, I did hack it up and stuff, but, you know, sometimes I can hack it up with the best of them. But it's a permanent repair, and it'll be fine. You know, I was kind of paying attention to the cuts that I make using my Dremel tool, trying to be very careful and strategic in the way that I bent the metal back, just making sure it wasn't putting strain on any of the other return bins for the condenser, and everything looked good. So honestly, I'm not even going to try to get them to change that coil. I think it'll last, you know, forever basically. I mean, until the unit's done. I've done these repairs before, and you know, you just got to be careful. And I can't stress enough about the thin wall of the condenser coil copper. It's not normal copper that they use. If you've ever tried to repair a leak and you've seen it flare up, you know what I'm talking about. And what I mean by flare up is when you put the torch tip on there, all of a sudden there'll be a tiny pinhole and then it just whoosh, it just opens up because the copper just disintegrates because of the heat. So you got to be very careful, and that's why I went through the process of dripping the solder on there, which is not conventional. You typically don't do that when you're brazing, but I dripped it on there and then melted the solder around the pipe instead of the normal process of heating it up and then applying the solder, okay? Just because I was very concerned about the copper flaring up and having, you know, pinholes turn into giant holes and stuff. So other than that, everything went good. I really enjoyed using the new FIELDPIECE micron gauge. I've been using that for a while, actually. I haven't been putting it in videos, but this is the first video that I made officially with it. But I really like it. I love that display on there. Something else that's really cool about the micron gauge is the, I mean, just little things, but obviously the display is awesome. The fact that it can communicate with the app, you know, that's a pretty much a given need on those things, but it is awesome and it is useful. You guys saw how I was doing it, you know, because I put the panel on the unit and I was able to still see what the micron gauge was reading. So that was really cool. The graph feature is awesome. It's a really cool gauge. Oh, but the thing that I was trying to point out is the coupler, the little 45-degree angle coupler that comes off. Something that I thought was really unique about their coupler as opposed to any of the other micron gauges that I've had is there's actually a Schrader depressor in both ends, which doesn't seem like you're going to use it very much, but it's really neat because sometimes you can't get the micron gauge coupler into a weird spot and you can actually flip it around and it still has a Schrader depressor on the other end. So that's just something silly that I noticed about it that I thought was pretty cool. But overall, the repair, I think, went well. Something to understand is the more fittings that you have, the more potential you have for leaks. And what I mean by that is I had, because this unit has those CoreMax high flow Schrader cores, right? And you can't put a normal core removal tool on there. So I had to use Schrader depressors, okay? Those Schrader depressors, I haven't had a lot of luck with those not leaking. They've leaked on me a lot, basically. But on one of them, I had to do a Schrader depressor and then a core removal tool. That way I could get the micron gauge on there too, okay? So the more fittings you have, the more potential you have for leaks. So just keep that in mind. Make sure you're keeping up on changing your O-rings and keeping them nice and good. Yeah, I mean, there's really not a whole lot more going on in there. As far as the VFD goes, I will bring that up to the customer. We're going to need to go in there and at least put a contactor. The downside to putting the contactor in on the one that I bypassed the VFD is, as it stands right now, if I just slap a contactor in there to where the blower motor turns on and off, you know, it's not going to run in heating mode. So we got to get that thing. We either got to put in a new VFD, we'll bring it up to the customer, or we got to find a way to permanently bypass the VFD where we can still run the heater and everything be safe. So I'll look into that and figure out what I got to do. I've heard from people that they figured it out. If you guys have a tip, I heard from someone, I didn't write it down when they told me, but it's actually like a really easy process. Supposedly there's like 2 wires. You just got to find them and then put, you know, splice ends on them and then plug it into the contactor. So obviously the VFD is going to probably take a 24 volt input from the fan terminal. So I guess I just need to find that wire, which wire is given the VFD 24 volts to tell it to turn on, and essentially hook that up to a contactor. But anyways, that's a whole nother thing for another day. If you guys haven't already, please consider supporting the channel. The easiest way to support the channel is simply just watch the videos from start to end without skipping through anything. You can do some other ways too. You can go to my website, hvacrvideos.com. We have merchandise available on there. You can also go to truetechtools.com if you're interested in purchasing any tools, such as the new MG44 micron gauge. Go to truetechtools.com. It'll pop up on their website. And if you guys use my offer code BIGPICTURE, you can save, at this point in time right now, it could change tomorrow, but at this point in time, you can save 8% on the micron gauge. I get a small commission from that. So that helps me, you know, by supporting the channel. If you guys know that you want to purchase something specific from TrueTech Tools, send me an email and let me generate an affiliate link, and I can also get a little bit more of a commission, and you can still use my offer code, okay? You guys can support the channel via Patreon, via YouTube channel memberships, via PayPal. There's links in the show notes of this video. So, yeah, I really, really appreciate you guys, okay? Remember, I go live on Monday evenings, 5 p.m. Pacific, work permitting, and also holidays permitting, because I, you know, will take off some holidays and stuff. And then I also go live on the HVAC Overtime YouTube channel with my buddies on Friday evenings, again, work and holidays permitting. And we kind of just talk about the week and hang out. So again, there's links to the Overtime channel in the show notes of this video. So I really, really appreciate you guys. If you guys have any questions, you can send me an email to hvacrvideos@gmail.com. You can also leave a comment on this video too. And that's it. We will catch you on the next one, okay?